Our initial idea was to combine all of the members in our group's heads together into one STL and then make an investment cast of the 3D printed figure. We would use the silicone to get a negative of the 3D print, pour wax into the negative, pull the wax out, and soak it in plaster. Then we would melt the wax out, leaving a negative that could handle the melting temperatures of the aluminum, and then would be poured into the mold. Finally, we would crack it open, leaving behind a perfect copy. However, through our design and build process, we learned many things about the nuances of turning real-world objects into an investment cast, and we had to change our design accordingly. In order to begin this process, we had to find a way to scan our heads so that we can make an STL mesh that could be 3D printed. Bryce found an app called Scandy Pro that could make a 3D model from just camera images. The Scandy Pro required images from all angles around the object, but from that it stitched together a 3D model. However, Scandy Pro outputted a lot of unfinished vectorizations or meshes, so our model looked rough and unfinished. We tried to complete the meshes by stitching them together in AutoCAD Inventor, but the mesh stitching just couldn't repair the data that has been lost. At this point, we turned to Thingiverse to find a solid mesh that could be easily edited and 3D printed. In Thingiverse, we found a Batman bust that we would use to make our investment cast. After the print was finished, our next goal was to create a silicone mold of the skull. Ian and Bryce poured a silicone mixture around the skull. Unfortunately, we had not glued down the skull print, so it floated to the top and ruined the mold. In our second go, we glued the print down and poured our mold and waited.
Zach then took a saw to cut out the silicone mold out of the PVC pipe. The 3D printed Batman can now be ejected from the mold. Batman did not want to come out of the mold. Ian pushed and pushed until he successfully dislodged the PLA Batman from the silicone mold. We could now fill this mold with molten wax.
After it was finished, we popped the skull out of the rubbery goo and Ian filled it with melted wax. The wax dried unevenly and it was extremely hard to pull out of the mold without suffering major breaking. Our group also began to notice the effects of making a copy of a copy and that the quality was suffering greatly. To create our plaster mold, we used plaster of Paris. Using a ratio of 2:1 plaster of Paris to water, using the wax casting that was previously made and combining it with the 3D printed riser made of PLA, Zach and Tatsuya made a plaster of Paris mold to be used for the final aluminum casting. After the plaster set, the mold was heated in a PID controlled kiln at 500 degrees Fahrenheit for an hour. While the PLA riser did not completely melt away, it became soft enough to be removed manually, and the main wax cast melted away, leaving a clean, hollow plaster mold. A sand jig was made to secure the mold in order to prepare it for the next step. Scrap aluminum was then heated in a stainless steel vessel at 1300 degrees Fahrenheit in the kiln and completely melted after 20 minutes. It was poured into the mold and left to cool for half an hour. Once it was cooled, the mold was broken open using a press and the aluminum casting within was extracted. Extraneous metal was cut and ground off, and the bust itself was polished, resulting in the finished product.
In conclusion, our team learned many valuable lessons, such that a project doesn't always go the way it was proposed. As engineers, we have to be open to changing our outline in order to get a quality finished product. All in all, we were happy with the finished product and the valuable experience we gained from all the small problems we ran into to get to the finished goal.